Can I test my presentation just to
Sure.
final check with.
So,
Like it.
this is the YouTube streaming address.
Sorry, I not see it. I have no presentation slides. Sorry.
Oh.
I'm just first testing that it's.
Main, can you see?
I can see that. I can see that. You are presenting.
Yeah.
No, I mean the in-call messages. I typed.
Yeah, but you put it there after I was turned
Right.
in the other tab where I was.
Okay.
So
after.
If I okay now this sharing works. At least for that.
Main, can you check the YouTube streaming?
Yeah, I saw that. I can see that. I can see that. You're presenting.
Yeah.
I mean, you can see that I echo now.
Yeah, but you put it there after I was turned in the other tab where I was.
Okay.
So
after.
If I okay now this sharing works. At least for that.
Main, can you check the YouTube?
Okay, sorry. I think I didn't see my slides at the YouTube video when I looked the playback.
Let me see. I'll go on the YouTube channel.
Yeah, there is some recording of the earlier stuff, and there was not my slides there.
Oh, okay.
So is the YouTube interface actually working correctly?
Yeah, in the YouTube channel, we can see that our current screen is on the right lower part.
Sure, but yeah.
I don't see that on Facebook yet.
Right, because I'm still working on
it. Okay, I will keep the YouTube link closed because it seems to confuse me at least.
Yeah, I will check YouTube. Lauren and I will check the questions from YouTube or Facebook. So you can just close the YouTube and Facebook link.
Right.
Good.
Because is on.
The Facebook you set up is 8 o'clock. It's not yet.
Not yet? Oh. Shall we start?
All right. Good evening, everybody. My name is Lapo Fanciullo. I am a researcher at Accademia Sinica, the Institute of Astronomy and Astrophysics. I'm originally from Italy, and I moved here to study the interstellar medium. That's the matter that fills the space between the stars. And that's the topic of my, the topic I'd like to talk about tonight.
So maybe Lapo, you turn off your YouTube channel.
The Institute of Astronomy and Astrophysics. I'm originally from and I moved here to study the interstellar medium. It's the matter that fills the space between the stars. I'm sorry, it's of my not the YouTube channel. Well, the topic seems to be a feedback.
Okay, I think it's okay. So I think someone didn't turn off the YouTube channel. Maybe Lapo, you
It comes from either Yu Meiying or Lauren.
okay.
Apologies, technical issues. Just a minute.
Okay, sorry, go ahead.
All right, so let me show you. My presentation. Can you see my?
Yes.
Can you see my screen?
Yes.
All right. So, thank you everybody for being here. As I mentioned, I came to Taiwan to study the interstellar medium, and so just to give some more details. I said the interstellar medium fills the space between the stars, but how did we find out that there is something between the stars? Well, the first hint was that there were in the sky there were holes where there seemed to be no stars, and for a long time people debated, is it because there's something in front of the stars that is blocking them, or is it just a region without stars inside? But it became clear that it could not be just an empty region, because it had to be, if it was an empty region, you could still see the stars behind. So clear there was some object in space blocking our view of the stars. And in fact, in the course of more than 100 years, we have learned a great deal about what is between the stars. So first of all, there is a lot of gas. What I call interstellar medium is 99% gas. And this gas can have very complex structures. It can form clouds. It can form denser clouds and more rarefied gas around them. So inside clouds, gas can be formed of molecules like gases on Earth. But outside of these clouds, the gas is so rarefied that usually atoms can be alone without forming molecules. And depending on the temperature, they might also be ionized. Of course, when I say dense gas in the interstellar medium, it's usually still very, very rarefied by Earth standards. It's a lot less dense than the air you breathe. And this gas is mostly hydrogen, about a quarter helium, and a very small amount of other gases. And then there is dust. Dust is very small grains of either silicates, that's the material that forms most rocks on Earth, or carbon, or even ice, not only water ice, but also ice from substances like ammonia or carbon monoxide, from the many substances you can find in space. And how do we observe this interstellar medium? There are several types, but it's usually very useful to look at different wavelengths. So not just in the visible light. Here you see a galaxy with a dark band in the middle. That dark band is interstellar dust. But if you look in the infrared, there the dust is not blocking light, it is emitting. And you see that there is a lot more of it than we could see in the previous picture. And people observe this in radio waves. And there you see a completely different object, two jets of gas emitted from the center of the galaxy. And you can also observe it in the X-rays, which traces the very hot gas. And you see these jets of gas that I mentioned before, but also more diffuse and very hot gas around the galaxy. So those are the basics of what I study, and I try to use different wavelengths and different types of observation to make sense and reconstruct what fills the space in between the stars. Thank you very much.
Hello? Okay, good. Greetings, everybody. I'm the other astronomer in the session. Thank you, Lapo. I'm Miikka Vaisala. I'm a scientist here at the Akademisnika Institute of Astronomy and Astrophysics, and I'm originally from Finland. As well as Lapo, I study Interstellar Medium, but what phenomena related to that is quite different. I think Lapo studies more of what it's composed of, and I study more of how it's moving. So let me turn on the presentation. I hope it's visible. So I'm talking about winds of the Milky Way, and here, well, this is just a poetic way of winds. It's just a poetic way of saying gas in motion, because, well, that's what it is. And it also tells you something, because if you look at our galaxy, if you see pictures of it and so on, and it looks everything is very, very still, but that's just an illusion of a human lifetime, whereas everything is actually quite well in motion. So I'm going to give you a little bit of a sense of how that is. So Milky Way is a galaxy. It rotates, it moves, and this is of course one thing there, but it doesn't only rotate. Like when we are looking at the interstellar medium, you are usually looking at the smaller thing than just the whole galaxy. So when we look at the more inner parts, how the motion is driven is actually by explosions, mostly. Also other kind of feedback from the stars, but especially the supernova explosions of stars. Those happen in surprisingly frequent intervals that if you look like this sort of a hypothetical speedrun image of Milky Way, it would go like bloop, 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 bloop. These things happen all the time in galactic sense, even though perhaps not in the human sense. And they bring a lot of explosive energy to all of the motion. So, but this is just a big view. So to get it a little bit more meaningful, we need to go more inside. And when you have this, how interstellar medium then is? How all this gas and dust is going in general? And yes, it is basically chaos, lot of complicated motions, almost random looking motions, which is not necessarily actually random. All sorts of chaos vortices, as I write here, and that's sustained motion by several explosions. Like explosions happens, more motions. Explosion happens, more of these motions. But it's not only pure chaos in sense of randomness. There is also then something inside, and usually what you mostly see are clouds. So there are areas, filaments, clouds, so on, where the gas and dust coagulate, condensate through cooling, through stuff being at around the same time, and through gravitational pull, because these things start to be massive enough that they can pull each other by gravitation. So what you develop are molecular clouds, but you develop all sorts of molecular clouds, big or small, that sort of things. And these often in the interstellar medium, what you see are the clouds, because those are the most noticeable things. The more weaker, diffuse, random fluctuation is less. But this is quite important to human life, because if you look closer, these condensations, these cores, can get so dense that what you have is that stars are forming. So while everything is movement, it also inherits the effects towards the collapse. There is enough gravity, enough mass to gravity to pull these things into each other, form a new star. So you have a core like this, it falls down, and then after a while it starts to inherit some features of rotation, whatever happens to be in the motions of the surrounding core, and then you get rotating disks surrounding these young stellar objects. And by some physics, which I don't have time to explain, you also get another kind of wind, which is the wind from protostellar accretion. So this is just an overview, but I hope it gives you some sense how everything moves in the Milky Way, and I'm happy to answer any and all of your questions you might have. Thank you.
Okay, so any questions? Then I probably ask one question, because according to the news, there will be a level X solar flare recently. So we know the solar wind will affect our daily life. So does the Milky Way wind, this movement, also affect the Earth?
That's a good question. I have to emphasize that when I use wind in my wording of the topic, it's more of a poetic expression, whereas solar wind is more of a more strict scientific term. But I can talk a little bit about the solar wind, as it's So what's different between the wind of the Milky Way and the solar wind is that the solar wind is basically these ejections of charged particles, electrons, protons, and so forth from the sun due to solar magnetic activity. That's its own question. Actually, some things apply also to sun and both interstellar medium, but that's another topic. Whereas wind in the case that I was talking about is something that is most of the time relatively slow for human scales, but it's something that you can kind of understand if you look how wind behaves. So you wouldn't say that is sort of a movement of interstellar medium for right now where we are. It doesn't have like direct immediate effect onto us. However, it is behind why there is like sun and earth and in some sense life, because the molecular composition of interstellar medium has significance to it. So perhaps it's not what happens right now over there is not so important. What happened a long time ago is very important.
Thank you. So any other question? Okay, since Lapo, I think you also do some observation. Can you share some cool observation experience with us?
Oh, it will be my pleasure. So yes, mostly I work on theory, but once every now and then I do observations, and my best experience there was when I went on Sophia. I can show a presentation that's an older one, but essentially this is a plane that does observations. So can you see this?
Yes.
Yes. So yeah, the idea is that there are you can have an observatory on the ground, or you can put observatories in space like Hubble. But there is also a sort of intermediate solution where people put a telescope on a plane, and so this plane can fly above the atmosphere, which is, most of the atmosphere, which is the main obstacle to observing. And people can use the telescope to observe space, and it is especially full of instruments that can observe the interstellar medium. I was very lucky because they usually don't need the person that requests the observation usually doesn't go on the plane. It happens rarely, but I managed to go there. There are scientists and technicians that actually manage the telescope. It takes it's a very complex, and it takes computerized commands, and I couldn't learn to do it before I went. But I went on the plane, and I could discuss with the other scientists that took the image the best way of taking the images to give me the kind of data I wanted for my studies. And this is my this is how it was on the plane. Yes, here I explain a little more. I'm studying this cloud in the Orion constellation. And let me see. Yeah, this is a lot of. This is I show how I prepare to go on board, and all of the safety features that I needed to that we need on the plane. So yes, and here is the instrument. As you can see, it doesn't look much like a normal telescope because it observes a different wavelength. It observes what we call the far infrared instead of visible light. And this was the image it obtained, the very first image we got from this cloud. So that was a very nice experience for me.
Okay, thank you. So other questions from students? So do you want to share both of your experience? Why do you want to study astronomy?
Well, in my case, it was sort of an accident. Well, not exactly an accident, but I really liked the science when I was a kid, and so when I went to college, I decided to study physics, and I wanted to do. I wanted to study, theoretical physics, but then there I met an astrophysicist, one of my professors, who was very good at making his subject exciting, and I fell in love with astronomy there in college, and then I went. And then at the end of college, I decided to continue and do a PhD on astronomy, and after that, I was looking for someone to work with, and Siska Kemper, who works at Academia Sinica, works on the same subject as I, so I moved here to work with her.
Okay, thank you. So, and you, Miikka?
Okay, this is going to be okay. So I started. How did I actually become an astronomer? I was actually a teenager, about 14-year-old, something like that, and I got some crazy idea into my head that I want to study space. I don't know. I don't exactly know why that is, but it happened, and I started to figure out, where you can study such things, and went for it basically. It's it's not perhaps how people usually choose their careers, but that's how it happens. I as for my particular subject matter, I was when I of course started studying astronomy, I had a very different idea that what astronomy is as a professional pursuit, and what you actually do when you are astronomer. But I got very interested in these computer simulations of just things in motion. I also read this book about chaos theory, which kind of got me interested in about chaotic phenomena. So I ended up then studying very computer simulations, how dynamics, how all the stuff moves around. It's something that requires basically two things. One is math, other is computers in some combination. And well, I came to Taiwan as as graduating from my PhD finally. I was looking for different opportunities. In ASIAA in particular, I got interested because of very strong emphasis on study of star formation, so that there's both people working on observations and theoretical matters related to the subject. And then I was also quite interested in kind of learning to work and live also in some environment of a very different culture than where I'm originally from, or so that's how I'm ended up here.
Okay. Actually, in Taiwan, we don't have astronomy department in colleges. So, do you have the undergraduate astronomy course or department in your country, or which major will you suggest the students to choose if they want to study astronomy in the future?
Okay, I can, or at least I have a response in mind. Actually, where I'm from, so I studied in Finland and University of Helsinki, and for University of Helsinki having very long history in astronomy, I mean about 400 years, there is an actual astronomy program. So I started with undergrad purely astronomy, but it's also very strong. You apply to the physics program and then you choose the kind of the sub program in the physics program, and that was so for bachelor's and masters and PhD. It's for me has been astronomy, but I think in many places where you don't have astronomy, I think very good option is to go through that. You go to study physics and then you look for like master's program or something which is more related to astronomy or space science. Another cute basis could be like computer science. Actually, my collaborators in Finland are nowadays working on a computer science department. So it's so especially in the kind of things that I do, this both directions where you physics or computer science, and then you go at later stage for masters, for PhD, depending on where you are. For astronomy, I think that's a good way to go.
Okay, so Lapo, do you want to share your experience or give some suggestion?
Oh, we got one question from the YouTube. Do you see the info messages?
There is some sound interference. Okay, seems to have gone. In my experience, but I don't know if that works outside of Italy, I started studying physics, as I said, and I think it may depend on the university, but the university where I was does not have an astronomy department. So I went to the physics department. But then from physics, I could specialize in astrophysics, and that's what I did during the master. So I did a bachelor in physics and then a master specializing in astrophysics. And then I did a PhD, but that was in a different university. It was in France, and that was from well, it was at an institute of astrophysics. So yes, at that point, let's say I started from physics and gradually moved to astronomy. And I think where I am from, that's the easiest option, but I don't think I know Taiwanese universities enough to say if it's the easiest way for people here. But it's certainly a way that works.
Yeah, actually in Taiwan, I think, yeah, most astrophysics they choose their undergrad major from physics, although I'm from math. Yeah, but yeah, I think go to the physics department may be most common choice. Okay, we got one question from YouTube. Someone asked, is the hole in the galaxies because of dark matter?
That with hole in the galaxy, I assume that you mean the hole I showed in the presentation, the hole in the stars. If so, it's not really dark matter. Even if it's confusing, I know, because it is a dark cloud, but it's not what astronomers call dark matter. So is this what you meant? Yes, what astronomers call dark matter is a type of matter that is still unknown and which is very diffuse, and its most important effect is that its gravity helps keeping galaxies together and groups of galaxies. Instead, the kind of matter I study, gas and dust, has it has a very small mass compared to dark matter, and so it cannot have the same effect. It doesn't hold the galaxy together. There is a connection there in that galaxies could form because normal matter, hydrogen, fell into big blobs of dark matter that had formed, and without that we wouldn't have the big amount of gas that formed the galaxy, and so also the gas that now remains between the stars. Yeah, they are so they are very indirectly connected, and what I show in my picture is not what people say when they say dark matter. I hope that was I hope that answered your question, but of course feel free to ask again if there is something I didn't cover.
I have one thing to add. So usually people who do like this sort of modeling that I do, like motions of gas, this sort of thing, I think that where dark matter is taken as a kind of essential component, you basically start to have models which you have the whole galaxy at least, or even a group of galaxies or something like that, very very big. But oftentimes, although I would think that in principle there is dark matter also inside the Milky Way, when we are modeling the interstellar medium in Milky Way, usually we don't look at the dark matter component because it's seen as not yet so significant in that scale.
Okay, any question from our audience? or because Lapo and Miikka are all from other countries, do you want to share what do you feel different? What's the difference between your country and Taiwan for the working experience or even the daily life?
Well, in my case, it's hard to talk about the working experience because when I was in Italy and even in France, I was mostly a student, so I cannot really compare. But something that changed a lot for me is I discovered a lot more about the history and politics of Taiwan that I didn't suspect could be so rich. And in my day-to-day life, I find that I eat a lot more at restaurants now. Well, not in the last few months, but because it's I no longer find ingredients to make Italian food, and so it's easier to eat outside than to make my own food now. And that is actually it works very well for me because here restaurants are very prices are extremely low. In Italy, food costs a lot more when you eat outside, so I would not have imagined I could just eat in restaurants every day and on a normal salary.
Well, when it comes to working in Taiwan compared to Finland, it's somewhat different. I mean, Finland is. We've been working in Finland. Finland is something like astronomy. It's it has this sort of a feature that there are not so many people doing that. So Finland has like 5 million people, which is like less than the population of the greater Taipei metropolitan area. So you have like two, 3 professors in the university, and then a handful of PhD students and handful of other scientists, and then so it's both. Yes, it's technologically it can be pretty advanced. Also, the quality is pretty good, but there are not so many people. So I find that ASIAA is much larger environment to work in than where I used to back in Finland. I'm more sociable with the people around. So and also with life, I think. Well, one very strong difference is two things: temperature and population. So when I'm here, it took me a while to get used to the fact that there's just so many people around, so many buildings around, not any empty space. On the other hand, when I went to back visit my home country after staying a while for here, it looked like everything is empty and there's so much space that I can fly an airplane between the buildings or something, because the streets are so wide and all that. It's so and Taiwan is very warm, very humid, whereas Finland we enjoy our minus 30 degrees Celsius winters, enjoying the crisp air, bright air of the winters, which I kind of miss now. Whereas, it's about the coldest Taiwan winter. The difference is like 40 degrees Celsius. So that's one aspect of that. Even in Taiwan, I find myself sometimes that the woods are calling, and I need to go. When I have my holidays, I go somewhere in the woods, in the mountains, away from civilization, as it's my cultural habit. Okay, there's some differences in life.
Yeah, but I saw from the TV news that even in Taiwan, even when you go to the mountains, there are so many people now.
Yeah, there are always these grandmothers and grandfathers with their radios playing some music there. I've even seen some people playing karaoke once and now when I was hiking. So it can be loud, yeah.
Okay, Laura is asking, do you celebrate Halloween in Italian and Finland? Because it's Halloween.
In Italy, we celebrate it now, but it's quite recent. It happened in the last maybe 20 years. Before that, when I was a kid, the idea was that it's an American holiday. We don't really do that, and then little by little, we got into the habit. Also, because it's always nice to dress up and get candy. So even if it was not our tradition, we adopted it. But yeah, it's not been for very long. The traditional holiday in these days in Italy is the Day of the Dead on November the 2nd, which is when traditionally you go to how do you say, offer your to show respects to your ancestors in your family. And there is also a specific sweet for that day.
So that's very similar as the Halloween, the similar spirit.
Well, yeah, the Day of the Dead, you don't go outside asking for candy. It's a different. You go to the cemetery to revisit your grandparents and great grandparents and so on. But yes, there is the connection is that there is a type of sweet for the holiday.
Okay, so it's more like the Tom Sweeping Day in Taiwan, I think.
Yes, it's a bit like that. Yeah.
So how about in Finland?
In Finland, we don't really celebrate Halloween. So yes, there are marketing as it's ubiquitous, which there's also the marketing which tries to bring the Halloween to Finland. Okay, if this international community, like in the big cities, all right, that's a different thing. But in Finland, nobody really celebrates Halloween. But nowadays, I see that as a kind of a response of this forced American cultural import of Halloween. There are some ideas of revitalize the old celebration of Kekri, which was sort of this end of the year, late autumn celebration, but that involves alcohol and goat masks and some weird things. I don't really understand it yet. That was how it was in the 1800s. But so we don't really celebrate Halloween. What Finland is more proud about is that we are claiming to be one of the countries where the Santa Claus lives. So the official Santa Claus is in Finland.
Okay, thank you. So any question?
Oh, I wanted to say you feel free to ask questions even if they're not exactly related to what we discussed before. Like even if it's not our specialization field, we'll do our best to answer any astronomy question or science question you might have.
Okay, Hannah, you may ask now.
Oh, can you hear me?
Yes.
Yes.
Well, there are a lot of subjects in astronomy, and why interstellar medium?
Sorry, what was the question? My volume is a bit low. Sorry.
There are a lot of subjects in astrophysics, and why both of you choose interstellar medium to study?
Well, that was also something that happens by coincidence, like how I got into astronomy in the first place. So I was doing an Erasmus. Do you have Erasmus in Taiwan? It's this thing where college students can go and visit other countries and learn in a different country. And yes, there I did an internship, a stage at an Institute of Astrophysics, and one of the professors there told me, "Oh, we studied this thing, and it was interstellar medium," and they told me that it was a chance to study something that had never been studied before, because they had just sent out the Planck mission, which is this satellite that observed the interstellar medium for 3 years, I think, 2009 to 2012. And they had finally gotten all the data, and they were starting to analyze it. And it was the first time someone observed so much of the interstellar medium at that specific wavelength. And so he told me, "Oh, this is something that has never been observed before." And I thought, "Oh, that's very cool." And I decided to work with him for 3 months for the duration of this internship. And at the end, he said, "I like working with you. Do you want to start a PhD as well?" And I said yes. And so that's how I got into this subject.
Thank you.
Yeah, I have a bit of a different way of going to it. One thing that I could say in general, if somebody wants to study like astronomy, like what you specialize in will quite a lot to depend on also the options available in whatever university you happen to be in, because usually astronomy, wherever you are, it's kind of a small subject, so there will be like a few different subject matter in the wherever university you are, which are the ones that are studied. So that is something that will quite often, about this actual opportunity, what you get exposed to more does matter. In my case, I think actually when my interest was okay. Interstellar medium looks nice if you look at the pictures, because it has shapes. It has colors in some sense, or at least fake. Okay, most of the colors in these sort of images are kind of fake, but there is still different properties of light. So it's kind of compared to then like stars which are like more point objects, or asteroids which look like potatoes in my opinion, or something like that. It was kind of more somehow felt like aesthetically most pleasing. also other thing was that I was interested in kind of chaos theory, chaos physics kind of stuff, and due to what sort of teachers I had where I was, Interstellar Medium was kind of natural direction for that at the time. So that's how it happened.
Thank you.
You're welcome. Any other questions? You can ask either text or by voice.
We got a YouTube question again from 7th grade. The question is, it's from Amy. She recently was reading A Brief History of Time from the Big Bang to Black Holes, and she would like to know, are there any books or YouTube channels for her to understand astronomy deeper?
Well, congratulations on your reading, because that's a very nice book, but also a very difficult one. I think I have a couple of ideas. One book that explains the history, a classical book that explains the Big Bang, especially, is called The First 3 Minutes. Maybe I can write the titles in the chat. That's a book about it's an old classic about the Big Bang and the period immediately after, and a YouTube channel that I like is called PBS Space Time. I also wrote that in the chat, and that is one channel where they explain astronomy and physics subjects. It can be on a very advanced level. So but that's what I like there. They try to take some very advanced matter and try to make it simple. Or yet another, if you don't like that, is there is a series called Crash Course, still on YouTube, and there is, of course, a section called Crash Course Astronomy. So that it also explains astronomy. Those are my suggestions.
Okay. Also, actually, I had in mind the PBS Spacetime as kind of a channel which seems to be pretty good production and also dealing with a lot of exotic, interesting subjects. Also, I would add a couple of channels here of YouTube. I have to totally admit that what I watch normally on YouTube is not astronomy, because I get it enough at work. but there are some, and there is one channel I think very astronomy focused called Astrom. I will put them on the on the messages the actual names, but Astronomy, which seems to very much focused on astronomy, and then one more general physics focused channel called the Science Asylum, which takes on some bit more complicated subjects. For example, what on earth are the tensors? Which is tensors being one subject which I work on, and I still don't know always how to explain them to anybody, except that they are things that do things. And also, I think, speaking of book suggestions, as I refer to this chaos theory book, it's the author is James Gleick, and the book name is Chaos. Hopefully I have written the name correctly, and I think that's a very popular book for as a kind of an introduction to chaos theory for people who are not mathematicians or physicists, and so many people who are interested in stuff like I am have read the book when they were younger. But that's one book that I think it's still available easily in English, at least. So now in the messages should be all the YouTube channels and the book.
Thank you.
Welcome.
So, any question? Because the time is almost over, so we may take one more question if you have.
Oh, sorry. I wanted to mention that I also wrote the author of the book I suggested, Steven Weinberg, author of The First 3 Minutes. You can find it in the chat.
Okay, thank you. Okay, so if no more question, maybe we just end here. Okay?
Okay, and could I suggest, if you like astronomy, you can also join the Astronomy on Tap event. It's this event that takes place in a restaurant, and where people, a group of astronomers meet, the general public, so they can discuss astronomy together, and there is an astronomical presentation usually. We used to do that every month. We stopped this year because of the pandemic, but we are starting again in December. You can look for Astronomy on Tap at Taipei on Facebook. Yes, Megan just shared the link. So if you want to know more, you can also check that.
Yes, Lapo and Miikka do a lot for the Astronomy on Tap in Taipei. So you're welcome to join them in the future. Okay, if no more question, then we'll end here. Thank you very much. Have a good night.
Thank you, everybody, for joining.
Thank you for being here. That
Thank
was
you.
great talking to you.
Appreciate. Thank you. Thank you all.
for sharing.
So
Good night.
good night. Happy Halloween for those concerned.
Yes, you too.
Good night.
Good night.
Good night.